Hi, I'm Andrew Wood, and today I'll be talking to you about applications of automation in manufacturing assembly processes. Now, you may be thinking to yourself, what is automation? Well, automation actually isn't just giant robots fighting each other. It's a wide range of technologies that reduce human intervention in production processes. Now, to really get a better understanding, we should look at the history of automation. Now, early sources of automation come from water wheels, steam engines, things of that nature. If you look at the water wheel, they really helped in grain manufacturing by removing the physical human labor to that of a water source. And that makes a huge difference between one person grinding and grinding and grinding all day, every day, 60, 70 hours a week. You know, they can only produce so much. With the introduction of the water wheel, all that grinding from one person now gets done in such a large amount by a water source. The water source puts all this power into it that one human does not have. So limiting the human intervention of it now produces more and more and more, and that's exactly what we're going for with automation, is we're trying to produce more. Now, from there, we look at the steam engine, which completely revolutionized the manufacturing process. Now, with all the power that we had from water wheels, now you increase that even further with the steam engine. All of the power that you have that produced from a steam engine is now pushing and pushing and pushing out as many products as you can with a larger power source, and that's all it is. It's a larger power source being able to produce more and more until you get the desired outcome. Now, in 1785, Oliver Evans had developed an automatic flour mill, which was history's first completely automated industrial process by being able to have continuous production without any human intervention. Now, from there, we move on to even more increasing production numbers, and you look at Henry Ford's Motor Company. They introduced the moving assembly line. Now, their technique consisted of two main elements, and those two elements ended up being a conveyor system and a limitation of each worker to a single repetitive task. So you have a machine come down an assembly line, one person works in a small area, finishes their job, pushes it down to the next station, and then this increased the production number that Ford's Motor Company had ever seen before. Now, the sheer number of the output that now was put into this just by reducing the amount of actual work that each person had to do helped speed up the process, and that's exactly what automation is going towards. Is going towards speeding up the process. It's going towards producing more. It's going towards, everything that we had just to be able to push out more and more and more. And that's where we get into robotics. So the Unimate, the first industrial robot, in the 1960s, it was introduced as a first commercial robot by George Devol. It was designed by George Devol with Joseph Engelberger, the father of the father of robotics. It was made at this company, Unimation, and they produced this robotic arm that was to help out factories. It was the first commercial robot mass produced for automation of factories. And in 1971, the invention of microprocessors resulted in huge price drops for computer hardware and allowed rapid growth of digital controls in manufacturing. With that, we step closer to the present, to more recent technological advancements like additive manufacturing, 3D printing, advanced materials, cloud computing, the Internet of Things, nanotechnology, all these new technologies that really go and help produce more and more and more by being able to reduce the amount of physical work done by humans. You look at any large company now, say Caterpillar, for instance. Now, they produce all sorts of construction equipment. So they're going to be pushing out as many machines as they can to fill their production numbers. And implementing automation into that means that now their quality gets better. The number of defects they have goes down. The price that they have to just be able to push out all these products goes down. All of these things that help produce more and more just goes into the work sector now. And now the most important part of it is the work sector and now how it's affected. Now there are positive effects like increased productivity, increased efficiency, better quality, but there's also negative effects like a larger skill gaps in the people that have to, do these jobs, and implementation costs and even job loss. Now, all of these go into the total cost of everything. Now, with your costs, there are so many different things. Training and education costs. There's downtime. And the total number of products being pushed down a line, now it has downtime to be able to have to stop and implement all these new processes, your maintenance, your, safety measures, everything that you have, software and programming, total return on investments. Now, your return on investments is everything that a company puts in, money-wise, to be able to produce all of this stuff. And all these return on investments are now how much money did I put in and how much money will I be getting back. If you really look into it, these are the things that you would need to know that affect everything, that really go into just this entire process. So with all of that being said about the history, technological advancements, how it affects the work sector, the costs of implementation, all of that, automation is a key foundation to the future of manufacturing processes. Now, these are my cited works. And with that, if you have any questions whatsoever, please feel free to email me at my email down below, andrewwood921@student.athenstech.edu. Please, any questions whatsoever, just shoot me an email and I can answer anything that you might have. Thank you so much for your time.